Hi everyone. What is Kirchhoff's law? This law was given by a German scientist, Gustav Kirchhoff. He suggested two laws, namely current law and voltage law. These laws can also be called first and second laws respectively. These two laws describe the behavior of current and voltage in series, parallel, and series parallel combinational circuits. It is also used to find the unknown basic parameters like voltage, current, and resistance in combinational circuits. Let's discuss the Kirchhoff's current law or Kirchhoff's first law. Kirchhoff's current law is defined as at any junction point in a circuit, the current arriving is equal to the current leaving. Or in other words, we can define that at any junction point in a circuit, the sum of incoming current is equal to the sum of outgoing current. In this picture, you can see the current I1 is entering towards the junction, where the current I2 and I3 are leaving the junction. When you sum the two outgoing currents I2 and I3, it must be equal to the current I1. If the current I1 is 10 amps, then the sum of the outgoing currents I2 and I3 must be I1. The outgoing currents I2 and I3 may be 5 and 5 amperes or 1 and 9 amperes or 8 and 2 amperes or 6 and 4 amperes depending upon the resistance present the path, but it should be equal to 10 amperes. If not, the circuit does not obey Kirchhoff's current law and the circuit is malfunctioning. Let us start with an example. Assume you have 1 liter of water in a bottle and you have divided the 1 liter of water into two other bottles. When attempting to measure the amount of water poured into two new bottles, it must be equal to or close to 1 liter, which is true. If it's mismatched, either your measurement was incorrect or you might have wasted the water while transferring it. In some circuits, you may have two or more branches of resistors. How many branches you may have doesn't matter, but all the outgoing current must be equal to the incoming current. Let us discuss this with more branches at a junction. Let the current I1, I2 and I3 are the currents flowing towards the junction, and the current I4 and I5 are currents leaving or flowing outwards from the junction. According to the current law, the sum of incoming currents I1, I2 and I3 is equal to the sum of outgoing currents I4 and I5 at any junction. Put the plus sign for incoming currents and the minus sign for outgoing currents. We can write it as I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Finally, we have I1 plus I2 plus I3 is equal to I4 plus I5. So, according to Kirchhoff's current law, the current that remains at any junction is 0. Let us assume the current I1 entering towards the junction is 10 amperes and the currents leaving or outgoing from the junction I2 and I3 are 4 and 6 amperes respectively. As per Kirchhoff's current law, at any junction, incoming current is equal to outgoing current. The incoming current is 10 and the outgoing currents are 4 and 6. 10 is equal to 4 plus 6, so we get 10 is equal to 10. Simplifying in algebraic form, it becomes 10 minus 10, which is equal to 0. So we can say that the algebraic sum of all currents at any junction is equal to 0. Let us apply and verify the current law to the electrical circuit. While dealing with combinational circuits or series and parallel circuits, always remember that in a series circuit, current remains constant, but voltage across the resistors varies depending on the resistance values. In parallel circuits, the voltage remains constant, while the current through each branch varies according to the resistance values. Let's have two branches of resistors R1 and R2 as 6 ohms and 4 ohms respectively, connected in parallel, connected to a 12-volt battery or DC source. Also, currents I1 and I2 flow through resistors R1 and R2. Current I1 and I2 can be found using Ohm's law, I is equal to V upon R. If I1 can be found by V upon R1 and I2 can be found by V upon R2, I1 is equal to 12 upon 6 equal to 2 amps and I2 is equal to 12 upon 4 equal to 3 amps. We get I1 and I2 as 2 and 3 amps respectively, and total current is 5 amperes. So at junction J1, the sum of incoming current 5 amps is equal to sum of outgoing current 2 and 3. Same way at junction J2, the sum of incoming currents 2 and 3 amps is equal to sum of outgoing currents, that is 5 amps. Hence, Kirchhoff's law is verified. To verify this in practical, connect the two ammeters A1 and A2 series with the resistors R1 and R2 respectively, enough to carry 2 and 3 amperes of current. And another two ammeters at before the junction J1 and after the junction J2, enough to measure 5 amps. Now, to the same circuit, add one more resistor R3 with 3 ohms between the junctions J1 and J2, so another current exists as I3 that flows in R3. Again, calculate the values of I1, I2 and I3 using Ohm's law. I is equal to V upon R. I1 is equal to V upon R1 equal to 12 upon 6 equal to 2 amps. I2 is equal to V upon R2 equal to 12 upon 4 equal to 3 amps. I3 is equal to V upon R3 equal to 12 upon 3 equal to 4 amps. So, based on the calculations, the total current entering at junction J1 and leaving at junction J2 is 9 amperes, which we can calculate by adding I1, I2 and I3. For the practical part, connect a resistor R3 with a series connected ammeter A3 between the junctions J1 and J2. Replace all the ammeters to be higher than the previous ones, enough to carry the current at each level. Close the switch and energize the circuit. Note down all the ammeter readings and verify that the ammeter readings are 9 amperes before and after the junctions, and A1, A2 and A3 ammeter readings are 2, 3 and 4 respectively. You can add any number of branches in parallel, but it should obey Kirchhoff's current law. If not, the circuit is not in parallel or you may have made mistakes in connections. Thank you for watching. Have a good day.